This is question 3 of the Poisson regression chapter of the Regression Models book. It says refer to question 1, fit your Poisson log linear model with drivers as a log offset. So this is to consider the proportion of drivers killed of those killed or seriously injured. So we did a little bit of this by looking at the binomial regression case. So I'm going to just copy and paste. Here's the fit. This is the fit with the offset. So all we need to do this is put in the offset of the log of the drivers. Okay? And if we want the fit without that, right, we of course just delete it, and that, let's call that fit 0. Okay, so I want to do summary of fit, just the coefficient table, and summary of fit 0. And notice it's very different model fits, and this is because these are very different interpretations. The model fit, the first one with the offset, is modeling the log of the expected value of drivers killed, okay, divided by the total number of drivers killed or seriously injured. Okay, so it's modeling the proportion of that as a function of beta naught plus beta 1x plus beta, and so on. In contrast, fit 0 is just modeling the log of the expected value of y by itself. Okay, so this first one is modeling this expected value relative to the total number of drivers killed or seriously injured, whereas the other one is just modeling the count by itself. Of course, those are very different interpretations. One is just saying, for example, this coefficient, the log coefficient, is looking at did the proportion of drivers killed among those killed or seriously injured, how did that change comparing before to after the law was enacted? In contrast, this one is considering what happened to the total number of drivers killed comparing before and after the log was enacted. Both of them are interpreted on the log scale, and of course you want to exponentiate them if you want to talk about the relative scale, comparing before in the denominator in this case to after in the numerator. Okay? So, for example, our law variable here says now it is flipped and gone, instead of being negative, it's about positive. So this is about 0.028. If we exponentiate that, it'll be about 1.028. So exponentiate of exponential of this thing should still be about 0.28, or about 1.028. So it's about a 3% increase in drivers killed among those killed or seriously injured after the seatbelt law was enacted, in contrast to a decrease in the number of drivers killed after the law was enacted, if we don't think about it relative to the number of total drivers killed or seriously injured. Now, I want to remind us another way we could have looked at this model. Let's say fit 2 is GLM. Let's was to do a binomial model, drivers killed, and this was covered in the last chapter. So drivers killed, and we want drivers minus drivers killed. And then we want family equals binomial. So now this is also looking at drivers killed as a proportion of drivers killed or seriously injured. Okay, it's not driver, it's drivers. Okay, so fit 2 should give estimates pretty similar to this first fit, and we see they are very similar, right? Negative 0.007, 2.53 compared to 2.6, 0.003 compared to 0.003, and then 0.03 compared to 0.028. So it's a slightly different model because it's a binomial model, and this other one is a relative Poisson model. However, we know because the Poisson approximates the model when the proportion is small and the proportion of drivers killed relative to the proportion of drivers killed or seriously injured is small. So these two models are going to approximate each other pretty well. But the important distinction is when you put that log offset, we're looking at the proportion, not at the raw number, not at just the raw number, not just the raw number of drivers killed. And this is a pretty stark example because some of the coefficients actually reverse their sign.